Hello friends, welcome to this video. In this video series, we would be solving previous year's CSIR-UGC NET questions of mathematics. Let us get started. This question is from Calculus of Variation and it appeared in June 2015 paper consisting of 4.75 marks. The question states that the extremal of the functional I is equal to 0 to x1 y square y dash square dx, which passes through the point 0 0 and x1 y1 is, you have to tell whether it is a constant function, a linear function of x, a part of parabola or a part of ellipse. So for solving this kind of question, we must know first of all what a functional is. A functional basically is a function of functions. What does that mean? It means that whenever you plug in a function here in the form of y and then you integrate it, you get another function. So this forms the general form of functional. To find the extremal of this functional, we have this equation known as Euler's Lagrange equation fy minus ddx of fy dash is equal to 0, where what is f of y? It is the partial derivative of f with respect to y, where our f is this portion. So see, in our question we have f of this form. It does not contain x. So we have a special case of Lagrange equation when our f is independent of x. So it goes like this: f minus y dash fy dash is equal to c, where c is some constant, and we will use this equation to solve our question. So in our question we are given f is equal to y square y dash square, and we need to calculate the partial derivative of f with respect to y dash. So in f we will treat this y as constant, so y square as it is, and we will take the partial derivative of y dash square, that would be 2y dash, right? And we will plug in these values in our extremal, in our Euler Lagrange equation, this one, right? So what we obtain is, we have this this calculations, and we just need to solve it a little bit to reach here. Basically I am naming this minus c as another constant a, and then again under root minus a as some other constant b. So further simplifying and solving, we have integration of y dy is equal to integration of b dx, right? So we have y square by 2 is equal to bx plus c, where these b and c are constants. They are constants which are to be determined, right? So how can we determine these constants? We have to make use of the conditions given in the question. So what conditions are given in our question? Let us have a look. We are given that the extremal passes through these 2 points. So the curve y satisfies these 2 points. So when we plug in 0 0 in this, we obtain c is equal to 0, and when we plug in x1 comma y1, we obtain y1 square upon 2 is equal to bx1 plus c, right? Sorry, c is 0, so we have just this. So this is the required extremal. Now obviously it has a form similar to our equation of parabola, which is equal to y square, which has a form equal to y square is equal to 4ax. So so the answer, what would be the answer? The answer to this problem would be part C, that the extremal forms the part of the parabola. Hope you like this video. Thanks for watching.